So for number 1, they give us this table. It says the temperature of a coffee in a cup at time t minutes is modeled by a decreasing differentiable function c, where c is measured in degrees Celsius. And they give us from 0 to 12, we have select values of c given in this table. For part A, we want to approximate c prime, and they even tell us to use the average rate of change over the interval from 3 to 7. So that right there tells us that we want to use c of 7 minus c of 3 all over 7 minus 3. So the numerator is going to give us the change in temperature, and the bottom is going to give us the change in time. So c of 7 is 69 degrees Celsius, and C3 is 85 over 4. And when we subtract those, we get negative 14 over 4, and we can simplify that to negative 7 over 2. Now remember that this is change in temperature over change in time, so that means our unit is going to be degrees Celsius per, and I think the time is, per minute. So there's our answer for part A. For part B, it says use a left Riemann sum with 3 subintervals indicated by the data to approximate the value of the integral from 0 to 12 of c of t. So first we want to approximate this integral. Notice that we don't have to interpret this. We only have to interpret something else, but that's going to happen later. Now it says use a left Riemann sum, and we're going to use 3 subintervals. So for the first interval from 0 to 3, we're going to use the left-hand value of 100. So that means we're going to take the interval width of 3 times 100. And then for our second interval from 3 to 7, we're going to use the height of 85. So that's 4 times 85. And then finally, the third, we're going to use 69. So 5 times 69. Now, this is the calculator section, so 3 times 100 plus 4 times 85 plus 5 times 69, and we get 985. So that is our approximation for the value of this integral. Now it says to interpret the meaning of this in the context of this problem. So here we have 1/12, 0 to 12, c of t dt. Now we can use our approximation, and so we take 985 and divide by 12, and we get 82.038. Now this formula right here is the average value of c of t over the interval from 0 to 12. And since c of t gives us the degrees Celsius, that means this is the average value, the average degrees Celsius. So 82.038 is the average temperature for the interval 0 less than or equal to t less than or equal to 12. That is the meaning of this expression. Now with letter C, here that says from 12 is less than t less than or equal to 20. So now we're going past the given table of values. And it says the rate of change of the temperature of the coffee is modeled by this formula C prime, which is measured in degrees Celsius per minute. We want to find the temperature of the coffee at time t equals 20. So we want to show the setup. So to find that, what we're going to do is we're going to take the last temperature that we know from the table, which is C of 12, plus, and we're going to add the change in temperature from 12 less than or equal to t less than or equal to 20. So C of 12, that's going to be 55. Now the change in the temperature, we're going to find that by taking the integral from 12 to 20 of c prime of t dt. Now, some would say that you would take the antiderivative and then plug in 12 and 20 into c prime, but the problem is we don't know that. So the only way we can figure out this value is by plugging in this formula into our integral. So I'll move the calculator over here. So my integral from 12 to 20. And our formula is negative 24.55 e raised to the 0.01. X is going to be our variable because we don't have t on our calculator. And for good measure, we're going to put in an extra parentheses divided by x. And so now we get our value of negative 14.6708. And so altogether, we get 40.329 degrees Celsius at t equals 20. And then finally, for part D, it says for the model defined in part C, it can be shown that C double prime equals this. So thankfully we don't have to find the derivative formula for C double prime, but they ask for 12 is less than T is less than 20, determine whether the temperature is changing at a decreasing rate or at an increasing rate. So the question is, essentially, is C prime of T increasing or decreasing? And so another related question is C double prime of T positive or negative? So that's what we're asked to do, is for this interval to figure out if C double prime is positive or negative. So a related question is, what about if C double prime is equal to 0? So when I set all of this equal to 0, notice that this part right here is always positive. And remember that we have the interval from 12 less than t less than 20. So that means this right here is also positive. And this right here is a constant. This is positive. Now the important thing here is that this part right here, this is negative. Now one thing you may want to do is you may want to justify that using a sign chart. Now we have 12, we have 20, and then over here we have 100. And so over here, this is going to be negative. At 100, it's going to equal 0. And then past 100, it is going to be positive. Now notice that it doesn't say show your calculations. It just says give a reason. So if we wanted to, we could just jump and say that the temperature of the coffee is changing at a decreasing rate for 12 less than t less than 20 because C double prime of t is less than 0 for all values in that interval. Okay. Hope this helps, and we will see you on the next problem.